Let's get on then to our first step. That's your 6 steps. Let's get on to our first one. The first step says that you must understand the problem and you need to have a plan. Let's see how we can do in that one. So let's read. Chemistry, in chemistry you need to read a lot. We say that 8 grams of commercial caustic soda are made into an aqueous solution of volume 200 cubic centimeters, 200 milliliters. Only 10 cubic centimeters, and that's where my proportion comes in. I'm only going to work with 10, but I must extend it later to 200. That's proportion. 10 cubic centimeters of this solution are neutralized by 14.5 cubic centimeters of a nitric acid solution of concentration 0.52 moles per cubic decimeter. Calculate the percentage of the commercial caustic soda, and there is my formula for using it. That's correct. Now, after you've read 6 sentences like that, I'm sure you've forgotten most of it, but this is the gist of it. They say that you use commercial caustic soda, you pour it, let's say you've got a beaker here, and you pour, and I've got caustic soda here, and I pour some caustic soda. Where's my caustic soda? Oh yes, my sodium hydroxide. Let's say I pour some of that in here. All right, so I pour some of that in there, and now I want to find the percentage purity of this. Now that's not easy, because this is, on the first stage, this is not pure. So I'm going to work with an impure substance. So how do I do that? I bring another one. What am I going to use first? I think I'll use nitric acid. Then I'll use some nitric acid added to it, and I do all my calculations based on the nitric acid first. And once the nitric acid has told me mole to mole ratio, how much moles I've used of nitric acid, I can deduce then how many moles of caustic soda I have in here. Over and done. Once I've got moles, I go into mass. Once I've got my mass, I take it over my original mass. Over and done. Let's go again. Impure. I don't know how to deal with it. Then I use something, a standard solution, that I know the concentration and the volume of. So once I've got the number of moles from CV, I then say ratio 1:1. Good. So if I have so many moles of this, then I'll have so many moles of that one. Once I've got my moles here, easy peasy, I go into my mass. And once I got my mass, then of course I can do my calculation. So I have to start from the bottom of my question. Look at the screen again and I'll show you what I mean. Why I say the bottom of my question? The question says calculate the percentage of purity. In other words, I know I have an impure substance. So this is how I'm going to do it. I'm going to say there's the 8 grams they've given me. Now, but this I know is impure. I can't use this one. I can't use the impure one. I can't use this 8 grams impure. So now I make a plan. I know what I'm going to do. I'm going to make this my total mass here, as I see in my formula there. That's my total mass, 8 grams. Now I must find the top mass. That's right. So I know it's impure. Now I'm going to find my mass of pure substance. That's right. And how am I going to do it? I don't know how to do it. Yes, I do. I have my nitric acid at hand. But let's say, example, I say the pure is 6 grams. Then I take that 6 divided by 8 and I multiply it by 100%. Then I have my percentage purity. Clever me, clever you. You better find out how to do it. We're going to step 2 now. Step 2 will tell us about how to use the nitric acid, find the moles, and then eventually in step 5 or 6 I come to the moles of the caustic soda or the sodium hydroxide that I have. Let's go to step number 2. Step 1 again, make your plan. Make your plan quickly, make your plan. Understand the problem and have a plan. And this is my plan. I have this now. I'm going to find out how much pure sodium hydroxide is there, and I'm going to use a standard solution for that. So let's go to the second step. Now they give me 2 problems in one. They say one, only 10 cubic centimeters is neutralized by nitric acid. Okay, and I have a volume of nitric acid, and I have a concentration of nitric acid. Let me go to this side. I have volume of nitric acid, I have concentration of nitric acid, and therefore I can find the number of moles. So I use my volume and concentration to find the moles. Let's quickly do that. So there is my 8 grams of sodium hydroxide, impure. I want to find how much purity is in there. Now I bring in the standard solution, the other chemical that I have, chemical substance that I have, and this is how I'm going to do it. There it is. Let's say I want to find out how much is in there. But in order to find out how much purity I have in there, I'm going to bring in caustic soda. Sorry, I'm going to bring in nitric acid, and I'm going to perform this operation, step 2, on nitric acid to find the moles. If I have those moles and I neutralize some of this, then I would know how much of this mole neutralized some of that mole. So I'm going to take it up at some stage, and then I will find out exactly, once I put the two together, I'm neutralizing the sodium hydroxide, then I will find how many moles I have. So I use this one to find the number of moles that is in here. And how would I use that? I simply write down the moles of nitric acid from that formula is C times V, because I have the volume and I have the concentration. I have the volume and the concentration of my standard solution. That's correct. And I put in the values. What is C? 0.52. What is V? 14.5 cubic centimeter. But for my very first idea, I must first convert to decimeter cube, because I can see my concentration is in decimeter cube. Okay, so let's do this quickly together. What do I write for C? 0.52. And what do I write for V? I write down the volume and I divide it by 1,000. Take note, I divide it by 1,000. Everybody's very happy. And then what do I do next? Okay, I simplify, and then I find my, that means it's 0.52, and that gives me 0.0145, no problem. And then I find my number of moles, and that is 0.00754. That is the number of moles of nitric acid that I have. That's right, 0.0754 nitric acid. Now, why do I want the nitric acid mole? That's very simple, because once I've got the nitric acid moles and I put it in here, neutralize it with an indicator, of course, then I know if I use so many moles, and how much is that again? 0.00754. Remember, don't round off in the middle of your calculation. Then once I got this number of moles, I put it in here, of course, with either pipette or with a burette or whatever I'm using to titrate. Then I find out, and my indicator, of course, then I find out know this number of moles. Then by balance equation, I can know this number of moles. No problem. You see how easy chemistry is if you understand your mole concept. Let's see what we have so far. We now have on the screen, we have 0.0075 moles of nitric acid from the given information. Clever student, the information will always be given. So that is step 2. And now I'm moving on to step 3. Yes, I have so many moles of what? Nitric acid. So my attention goes here. Here's my balanced equation. It is 1 to 1. There's the invisible 1 in front. Invisible 1 in front. So its ratio is 1 to 1. So what are the requirements? I must have a balanced chemical equation. And then if I know the mole of this side, which is 0.075, then I know the mole of that side. Can anybody please tell me what is the mole of sodium hydroxide while I quickly look up who's on my screen and who's logged in again? Please just stay with me for a minute. I see I have a visitor from Choma High School. Choma High School is a visitor. 5 minutes ago we switched in. Please send us some answers from Choma High School is a visitor. And the number is 073-402-7317. Welcome. And I'll look out for your WhatsApp messages in a minute. But what are we talking about now? We are now in step 3. Step 1 was make a plan. Step 2 was, well, let's find the moles of nitric acid, which I'm sure of I can find. Now I'm coming to the next step. I balance the equation between the two, and the ratio is 1:1. So I know this one, I'll know this one. That's the plan. Let's quickly see and have a look again at our screen and see if it is so. So now, I now have ratio 1:1. Is that true? So what am I going to do now? I'm going to take the nitric acid, add it to the sodium hydroxide. Nitric acid added to the sodium hydroxide. Here we go. Let's do it. Add it to it. There we go. So that is 0.0745 mole. So a little bit. So now I know in that piece of the sodium hydroxide is 0.0754. Okay, now what next? That's my chemical. I've got him. I must deduce the number of moles now. But the sodium hydroxide to nitric acid is 1:1. I can see it there from the coefficients 1:1 moles. And then what do I do now? Then I write it as the number of moles of nitric acid is equal to the number of moles of sodium hydroxide, and therefore the number of moles of sodium hydroxide is also 0.0754 mole, just like it was for the nitric acid. And I'm asking myself, am I clever or am I not? I actually figured out, without knowing this was impure, I actually used another measurement, another standard solution to figure out these moles. Am I clever? Are you clever? You sure you'll be able to do it? Then please do it in the future. Now, let's just summarize what we've got so far on the screen again. So therefore, I know that that little piece of sodium hydroxide is equal. That's why we say deduce now the number of moles. That little piece there is what the nitric acid covered, and it's 0.0754 mole. Now, my question to you is, now that I know, can I speak to you? Now that I know a tiny bit is 0.0754, how am I going to find out the number of moles in here in totality? How am I going to do it? Simple proportion. Simple proportion. I've used 10 cubic centimeter, but the total in here is 200 cubic centimeter. So what's the ratio? 10 is 200. So how many times must I scale up this number of moles now? You got it? I'm sure you've done your mathematics and your homework very well, so you know how to do it. Let's quickly look at my screen and see how far we are now. We are now at step number 3. And step number 3 tells us that we must always take note of the balanced equation, see the mole ratio, which is 1:1, and if that one is 0.0754, then this one is also 0.0754. And therefore I know that small piece where the nitric acid landed, that is 0.0754 moles. Now I must go to step number 4.